Thank you for joining us today for FI Consulting's webinar, Managing Model Uncertainty, Stress Testing, and Sensitivity Analysis. Lines have been muted to reduce background noise and to ensure the best audio quality. If you do have questions, please use the GoToMeeting toolbar and the question function that you find there. Today's presentation should last, I think, until just before 1 o'clock Eastern Time. We will have a brief period before wrapping up of Q&A, and if you could submit your questions again through that GoToMeeting toolbar, we'll be able to consolidate those and go through them as part of the presentation. After today's event, we will follow up with participants as well as other registrants that maybe were unable to attend and share the recording of today's webinar as well as the materials we're going to share. One of the pieces of interactivity we're going to use as we go through is polling, and we have 2 questions that we'll pose to the audience, and we hope that you'll please participate. It is an anonymous poll, but it's a good way for us to get a sense of how the audience is involved with the 2 techniques we're going to focus on today. So I'm Larry Roadcap, and I lead the commercial financial institutions practice here at FI Consulting. You know, we were thinking about this webinar and decided that we would focus on model risk and how to quantify model risk after we've experienced a particularly strong wave of interest in model governance, risk management frameworks, and independent model validation. I think in particular as organizations have begun to more aggressively challenge their champion models and models in production, they've been looking for more advanced and really complex approaches to model uncertainty in many ways. And so with the work we're doing, we're often called in either to act as an independent validator or to work with teams that have been set up for independent validation. Today, we're going to look at 2 approaches for quantifying model uncertainty, both which contain components and techniques using SAS and R, in which we look at data inputs and take into account that we rarely have perfect data sets, and of course that impacts model output. And in this approach, we'll be looking at how do we understand how big that error and how big that impact is on the modeling outputs. For those of you who aren't familiar with FI Consulting, we are a boutique risk analytics and financial modeling firm with our primary office in Arlington, in Roslyn, just across from Georgetown in Virginia. We've been in business for just over 12, I think maybe even over 13 years, servicing the needs of government, GSEs, and commercial financial institutions. We focus on 3 or actually 4 areas as core strengths, the first being data, the second being analytics, the third modeling, and the fourth technology. And I think that we're particularly well known for our expertise that has been developed over more than a decade in the credit risk space. Today we have 2 presenters joining us. The first is Rob Chang, who is a consultant that has been with FI for just over 3 years. He brings to his work more than 15 years experience across capital markets and banking, and holds a master's in mathematical finance from Columbia University. He also holds the FRM designation. Our second presenter is Vadim Bondarenko, who has been with FI more than 5 years and brings to his work 16 years experience across investment management, banking, and a considerable resume while at FI working at U.S. Treasury. He holds a master's in applied economics from Johns Hopkins and holds the CFA designation. So before we jump into model uncertainty and looking at sensitivity analysis, I'd like to just take a quick poll. You should see shortly a question appear and have an opportunity to respond. We wanted to ask the audience, how often do you use sensitivity analysis in the context of model validation? And shortly you'll see the poll open, and if you could kindly respond, choose from one of the selections of always, sometimes, rarely, or never. Okay, we'll be closing the poll in just a few seconds. Great, and it looks like we're almost evenly split between always and sometimes. It's pretty impressive because I think for us, even the most advanced institutions are just beginning to find ways to automate and systemically apply these more advanced and quite data and quantitatively intense approaches to quantifying model uncertainty. With that, let me please hand over now to Rob Chang.
All right, thank you, Larry. Okay, so we're going to talk about model uncertainty first and see if we can define the term a little bit more precisely. So what is model uncertainty? The chart shows how uncertainty in model inputs, whether they be through data collection or parameter estimation, leads to uncertainty in model outputs. The green is more variation in its range of outputs relative to its range of inputs. For a linear model, such as an ordinary least squares model or binary logistic regression, some of the model uncertainty can be captured by the coefficient estimate. However, for nonlinear models, the uncertainty might be a little bit harder to quantify. Okay, so here's another chart that separates the uncertainty of a model into two parts, the calibration uncertainty and the prediction error. Whenever we calibrate a model, we're uncertain about the calibration conditions, so there is some inherent error, illustrated by the first part of the graph. However, there is even greater uncertainty in the prediction error, because not only are we uncertain about the calibration conditions, but we're also uncertain about the future conditions for which a prediction model is necessary. So you can see that the prediction error is almost always going to be greater than the calibration error uncertainty. All right, so the overall precision of any model depends on its data measurement, parameter estimation and values, the model structure, and the model algorithm. And why is the model precision subject to uncertainty? Because we have uncertainty in the model design. Some models are inherently uncertain. Maybe like a stochastic model or a non-deterministic model will always have inherent uncertainty. And then there's also uncertainty about the parameters. Any estimation procedure is always going to give you some model error that is always going to have uncertainty to it. We can also are unsure about the data collection. Data collection both from a temporal point of view, meaning the timing of the data collection, and also the data itself. However, while we can't really quantify uncertainty, we can develop tests for it. So we can test the linear relationship or the monotonic relationship between the input and the output variables. And we can also perform tests of location or central tendency. And we can also test the difference in output variance. Okay, so now we are going to look at some concrete examples in sensitivity analysis and bootstrapping. And we're going to start with sensitivity analysis. There are many different ways to conduct sensitivity analysis. However, we're going to focus on two of them. The first is parameter space exploration. And we're going to make that easier with a numerical technique called Latin hypercube sampling. As an example, we're going to use Latin hypercubes to perform sensitivity analysis on a simple deposit spread model that tells banks how much they should charge on deposits below the market interest rate. And our second type of sensitivity analysis test is called perturbation analysis. And this is what is most commonly thought of as defined as sensitivity analysis by the Basel Committee and other regulatory bodies. What this is we're going to make small random changes to the data in all directions. And then we're going to recalculate our model with the altered data. For this example, we created a simple logit model for a single-family prepayment. And we're going to alter the variables of our prepayment model, for example, LTV, mortgage rate, income. And then we're going to recalculate our logit coefficients. And by the way, both of these methods will work well for many types of models, both linear and nonlinear. Okay, so what is Latin hypercube sampling? Latin hypercube sampling is a way to generate efficient samples that adequately cover a parameter space with little overlap or redundancy. This will help speed up computation time and produce stable output. The stained glass window that you see is an example of a Latin square, as there is only one occurrence of each color in each row and in each column. Now on the left, we have a random uniform sample using standard Monte Carlo techniques. On the right, we have a Latin hypercube sample. We can see that the Latin hypercube sample evenly covers the entire parameter space with a relatively small number of samples. For complex models, this is extremely important for computation time and efficiency. The step-by-step approach is to generate samples from the parameter space. And we need to ask ourselves, is it necessary to run every parameter combination, as some combinations are not meaningful? We are also able to choose different probability distribution functions for each parameter, as you'll see in our example. Then we're going to run the model with these samples and choose our simulation size. And then finally, we're going to perform testing that measures the association between each input parameter and the model output. Okay, so for our example, we are going to have what's called a deposit rent model that tells banks how much they should charge below the market interest rate. And our deposit rent model is going to use 4 parameters, the growth rate, the market interest rate, and 2 risk premium factors, A and B. So you can see the equation for our model below, and some example parameters. The market interest rate is going to be 4.39%, the growth rate 7.3%, et cetera, et cetera. And that will produce a spread of roughly 75 basis points. So we want to see the effect of changing the parameters G, A, B, and R on the deposit rent. So here we're actually altering the parameter itself. We're going to assume that the growth rate and the risk premium factors will follow a normal distribution. However, you can put any type of distribution you want, but for the purpose of this example, we're going to assume normality. And just to show you that we can use different types of distributions depending on the type of parameter, the market interest rate is going to follow a uniform distribution. We then create 3 objects in R. The names of the parameters, the distribution function, and a nested list containing the parameters to the distribution functions. So here, is a vector of our different probability distribution functions. So you can see that the first three entries are normal, and then the last one is uniform. And then here are our arguments. So for the normal distribution, we can list the mean and the standard deviation, first and second moment. And for the uniform distribution, we're just going to list the minimum and the maximum that it will draw from. We then create a wrapper function using the function mapply. Our wrapper function will apply the 4 parameters to the model and then return a single output value. So I've highlighted our equation again, and that is our model that we put inside the wrapper function. And the wrapper function will only run one instance of the function itself. Then the simulation will come in the mapply function, where we're going to apply the model to all the different parameter combinations. We then use the Latin hypercube function to generate a hypercube for the model. So we're going to pass the model, the parameter names, and the parameter PDFs to our Latin hypercube function. So you see here we have some inputs. We have the model. We have our vector of factors again. And then we have our arguments again, specifying normality for the first 3 factors and a uniform distribution for the last factor. So then we can view the samples generated and confirm that the Latin hypercube procedure is generating a well-balanced sample according to the probability distribution that we specified. So I've highlighted the first row for you, and you can see that A, B, G, and R contain reasonable values that might be associated with drawing from the probability distribution. We can then visually examine a scatter plot of the result as a function of each parameter. This is a useful sensitivity analysis tool, as all the parameters are being slightly changed for each run of the model. The partial rank correlation coefficient will measure how strong is the linear association between the result and each input parameter after removing the linear effect of the other parameters. So I've highlighted the first column here for you, and we can see that parameter A has a negative correlation along with parameter B. G has a very little correlation effect on the model, and R has a positive correlation with the final output. And we can also chart the partial correlation coefficient as well as the confidence intervals graphically. Okay, so now we move to our next test, which is perturbation sensitivity analysis. And remember, this is when we introduce small random changes to the data and then recalculate the estimate. So the step-by-step approach is to specify the data, the model, and then all the corresponding probability distribution functions. Then we are going to draw from those PDF functions to introduce small random changes to the data. We then recalculate the estimate using the altered data. And then finally, we test how sensitive was the parameter estimate from randomly changing the data. If your estimate differs greatly from your original estimate, that means that you have an unstable model. Okay, so looking for our example, we're going to add random noise to variables that predict prepayment, such as loan-to-value ratio, the mortgage rate, and income, and then we're going to re-estimate our prepayment model. So I've highlighted one of our records for you. We can see the loan-to-value ratio is 97%, interest rate 6%, annual income, etc. And then I've also highlighted the last column that has our ones and zeros for our binary output variable for prepayment. A 1 means a loan prepaid, a 0 means a loan did not prepay. We're going to use a generalized logistic model. However, the package perturb is compatible with many different model types. So the first thing we need to do is specify our output variable, and we use the GLM function in R. for a generalized linear model. And then we are going to specify that it's a binomial model corresponding to the binary distribution of our output variable. Now, after we estimate our logit model, here are the coefficients of the intercept. Now, we're going to later compare these coefficients to our coefficients generated from the perturbed model. We then determine the magnitude of perturbations. Again, we can draw these perturbations from either a normal distribution or a uniform distribution. So again, we have to pass our model. We then specify the variance of our normal distribution. So if I put all ones, if this is a vector of ones, that would mean it would be drawing from standard normals. We don't want to draw from standard normals, so we have assumed certain variances for these variables. We don't want a uniform distribution, so that parameter is false, and we're gonna draw 100 iterations. Okay, then we check that the estimates based on small changes are unstable. So what I've done here is I've highlighted our intercept and our coefficients for the mortgage amount and the loan-to-value ratio. And these are the ones based on the sensitivity analysis. And if you compare them to the original coefficients, you'll see that they're quite similar. Again, for the interest rate, UPB, monthly mortgage payment, if we compare those to the original coefficients, again, we see that they're quite similar. Okay, now I'm going to pass it to Vadim, who's going to talk about bootstrapping.
And before we start with Vadim, I wanted to just poll the audience one more time. This is a similar question, this time really looking at Bootstrap. And how often do you bootstrap your parameter estimates when developing a model? And I'm going to launch this poll now and ask that you respond. We'll close the poll in just about 5 seconds. Okay, I'll be closing the poll now and sharing our results. It looks like 100% of all participants are using bootstrapping during development. This is a pretty impressive outcome. I don't think that we come across too many organizations that are using this sort of complex approach, particularly because it is, pretty manually intensive and difficult to run. But with that said, let me pass it over to Vadim, who will introduce us to the Bootstrap approach.
Okay. Thank you, Larry. Thank you, Rob. Good afternoon. My name is Vadim Bondarenko, and I'm a senior analyst with FI Consulting. And at this portion of the presentation, we'll talk about the Bootstrap approach to managing model uncertainty. So first, I want to describe the basic intuition of the Bootstrap, and then go over some of the practical application in validating regression models. So the basic concept of Bootstrap can be described as a simulation-based procedure for estimating and validating distributions and deriving robust confidence intervals. And you might ask, why do I need to use the Bootstrap for that when I can simply examine the actual distribution of my data or look at the confidence intervals in my favorite statistical software package? And so first, it is useful. The Bootstrap is useful when the theoretical distribution of a statistic is complicated or unknown. The Bootstrap method is flexible enough to capture almost any level of complexity. Okay, in addition, you might not always have enough data to make meaningful inferences based on theory. And with the Bootstrap, you can use the data you already have to simulate more observations. And finally, And finally, your model may be based on certain assumptions, and you as a model validator might be interested in testing them yourselves. Okay, so to illustrate the bootstrap, how the bootstrap works behind the scenes, I will use it to derive an empirical distribution and a confidence intervals for a median for a series of numbers. For example, let's pretend that we have a sample of numbers 1 through 9, and we assume that it has been drawn from a larger population of similar numbers, and we can see that the median in this case is 5, and we are interested in the 95% confidence interval for this median, and there's actually no analytical way of doing that, but the bootstrap lets us accomplish that goal with using just these 9 numbers. You can think of the bootstrap as the process of creating many samples from the original sample. We'll start by randomly picking 9 numbers from 1 to 9 with replacement, and we'll repeat it 10 different times. And so this is what it looks like. We have our original sample, and here's sample number 1. As you can see, it's the sample from the original sample, and it's of the same length. And since we drew it with replacement, note that some of the numbers are drawn more than once, for example, number 4, and some numbers are not picked at all. The median in this case in the middle column happens to be number 4. And here's another example, another sample. Again, the median in this sample is 2. So we repeat this process until we have 10 different samples and record 10 different medians. As we sample our data, we can see the natural variability of the median using only the 9 numbers we started with. Given these 10 random samples, we can make a note of different quantiles and of the medians of those samples and plot their distribution. Of course, having only 10 different samples is not enough to make any meaningful inferences, so we repeat the process 100 times to get a nice-looking bell-shaped curve of the distribution. And now we have enough data to look at the 5th and the 95th percentile values, and we can say with 90% confidence intervals that our median is between 3 and 7. Okay, so now we move on to applying the bootstrap method in the context of model validation. We begin with validating the stability of regression coefficients by bootstrapping their confidence intervals. We use a dataset consisting of 1,000 consumer credit profiles obtained from a German bank. For each borrower we have a binary variable called credit. In addition, we have 20 variables that are assumed to influence the credit quality of each borrower. We use these 6 variables to fit a simple logit model that estimates the probability of having a good versus bad credit profile. And so these are the estimated coefficients, followed by their standard errors. And given these standard errors and making some assumptions, we can mathematically derive their confidence intervals. Or we can calculate the p-values and test their statistical significance. In addition, we will use the same bootstrap procedure illustrated before to derive confidence intervals that are more robust. So the top row here is our original logit estimates, and we'll fit the model for every bootstrap sample. And in the following rows below that, you can see the coefficients from each one of the bootstrap samples. And if you look at any of the columns, you can see how the coefficients vary from sample to sample. We can visualize this variability of a single coefficient by plotting a histogram of its values, estimated from 1,000 repetitions. You can see that the orange bell curve is the normal distribution based on the parameters from the original model. And we can say that overall the normal curve appears to fit the data pretty well. However, as you can see in the right tail of the histogram, there is some blue bars that are actually exceeding the normal distribution, which may indicate a violation of the normality assumption and signal the presence of bias in our estimate. We can also look at the 95% confidence interval implied by the original model, which is the thick orange line at the bottom, and compare it to the confidence interval based on the empirical percentiles from the bootstrap estimates, which is the big black line at the bottom as well. As you can see, the bootstrap confidence interval is much wider and it's skewed slightly to the right. And here's another same plot for a different coefficient. As you can see, the bootstrap confidence interval is actually narrower in this case than the one implied by the model. So we can also examine the multivariate distributions of regression coefficients. So on this graph, each blue dot represents two coefficients plotted along the x and y axes. And we can visualize their joint confidence intervals for these two coefficients. So the orange dotted lines represent the 50%, the 95%, and the 99% joint confidence intervals for these coefficients. All right, so next we'll try to estimate the true level of a model's predictive accuracy by bootstrapping the same data that we used for fitting that model. To put some context around it, we can say that if we use the same data to train the model and to test its accuracy, the results will be too optimistic. We can call this measure of model performance the apparent accuracy rate. And obviously, a better way of testing model performance is to test it on a related but a separate population, like from an adjacent geography or another time period. But if we don't have additional data, we usually have several methods to obtain realistic estimates of our model accuracy as compared to an apparent rate. So the most commonly used methods include splitting the data into training and testing data sets using cross-validation and also the bootstrap, which we'll discuss here. So this is a receiver operating characteristic curve for the logic model that we showed before. And I chose the area under the curve of the AUC as my performance metric because it's a commonly used measure of prediction accuracy for these classification models. But other measures of accuracy could be used as well. For example, when predicting continuous variables, you could use the mean squared errors instead. And so the apparent AUC for our model happens to be 0.684. And since we scored the same data set that we used for training the model, we know that this is probably too optimistic. And so we can estimate this level, the level of this optimism with the following procedure. We take the full sample of the data, and then repeatedly generate bootstrap samples and fit our model to each bootstrap sample. Then we use it to make two sets of predictions. First, we predict the values for the bootstrap sample itself, and second, we predict the values for the original full sample. Then we calculate the levels of accuracy in each case, and we expect the bootstrap sample predictions to be more accurate since the same data is being used as for training the model. That's why you can see the orange circle is larger than the blue circle. And then the difference between those two would be the level of optimism inherent in our data. So this is what it looks like with our bootstrap samples. These are the AUC from scoring the bootstrap samples that were used for training the model. And these are the AUCs used from scoring the original full sample. As expected, the average of these is lower, indicating less accuracy. And we can take the difference of their averages in the third column to obtain the estimate of the optimism inherent in the apparent accuracy rate. So with only 10 bootstrap samples, we can say that our apparent accuracy rate is 0.016 too high, and we can subtract it from our original estimate of 0.684 to get us the adjusted AUC of 0.668, which we can say is probably more realistic. And also just the advantage of this method is that we didn't have to make any assumptions about the distribution of the data or the mathematical properties of our performance metric or the AUC. And so to summarize, here's some points to keep in mind. As I mentioned, we can use Bootstrap to examine the distribution of a statistic or a model output of almost any complexity, including the goodness of fit, significance of parameters, your various residual diagnostics or prediction accuracy metrics. It would make sure that your sample is representative of the population and that the observations are independent from one another. With the Bootstrap, we let the data speak for itself and challenge model assumptions, but we still need to be careful about designing the process. And also a few practical points for actual implementation. As I quickly realized myself, from going from a textbook example to a real model with actual data, bootstrapping becomes very computer intensive and time consuming, especially for complex model and large data sets. So it makes it a great candidate for splitting the job across a cluster of computers or a local CPU cores, which significantly cuts down on processing time. Also, since it's based on random sampling, make sure to set the seed to be able to replicate your results in the future. I would start with a simple model, small data set, few repetitions, and then validate the code and the results carefully. And then after everything's working as expected, add more complexity to the data, add more complexity, more data, so you can kick off a much larger and time-consuming job. If you're using SAS, simply write a macro with a proc survey select procedure for random sampling. If you're using R, there's a number of packages and functions that you can use. And finally, I posted the R code for reproducing all the examples at this link in case you're interested. And that is it for me. Thank you for listening.
Thanks, Vadim. We'll be providing these materials after the webinar to you with this link, so no need to scribble it down right now. We'll make sure we get that to you. I hope that you found the presentation useful. We did try to focus on ways that you can challenge models, confirm their predictive power, and measure accuracy and model uncertainty as part of an that I would like to open the floor to questions. As we mentioned in the introduction, you can use the question function that is within the GoToMeeting toolbar. Okay, we have quite a few questions here that have come in. The first that has arrived is related to cutoffs for sensitivity analysis. How do you determine the cutoff for sensitivity analysis? What is a critical variable?
Okay, that's a really good question. Basically, I feel that a sensitivity analysis test should alter the data slightly in a significant way, however, not really go to the extremes of the parameter range, because then you're kind of getting into stress testing and maybe even scenario analysis. One of the rules of thumb is to move the data by one standard deviation. But if you're moving it by one standard deviation, that assumes that you know the probability distribution and you have enough data to make an accurate judgment as to what one standard deviation is. What's also interesting to know is that it's much more interesting to look at combinations of parameter changes rather than looking at them in isolation. So I think it's far more important that you move each parameter by a set amount and look at the result that way rather than focusing on the cutoffs of a single variable.
Great, thank you, Rob. Our next question is related to bootstrapping. Is bootstrapping just another type of sensitivity analysis? And I'll hand that over to Vadim.
Yes, I think you can definitely think about it this way. I think the key difference with Bootstrap is you actually using the data to kind of perturb and test the sensitivity of your model but you don't make any assumptions regarding the the distribution of your perturbation or any of the parameters. You simply kind of create a new data generating process that is similar to your existing population. But I think the idea is between it's still doing kind of the same idea for validating your model using both methods.
Great. Well, I want to thank everyone for attending today. We have run out of time. Again, we look forward to presenting a series of these throughout the year. I do believe we are thinking of a visualization webinar as our next event sometime in September. In the meantime, if you do have any questions regarding today's presentation or want to find out more about FI and what we do, please don't hesitate to contact us. Our details are there on the screen. And again, tomorrow you should be receiving an email with a link to today's recording as well as the presentation deck. And our information is in there. Thanks again, and I hope you have a good day.
Okay, Sue and Victoria, are you still there?
Yeah, we are.
Great.
No. It's probably just noticed a couple of things that wanted to make you aware of that were going on during it. First of all, we really need to get that poll thing figured out because both times we had a blank screen after.
It goes back to the waiting room screen, and I thought we just talked about just keeping the poll results not showing them and just talking about them. That might be an easier transition. What do you guys think?
Yeah, I agree, because what happens is when we close a poll, the audience, the screen goes away, basically,
Right.
and they have to get it back by clicking on something.
So the screen being the GoToMeeting screen.
Yeah, the GoToWebinar window.
So if we do a poll, we open it, and then we close it,
And we don't show the results.
and we don't share.
Yeah.
We have to.
You can just, or just tell people what the
The majority, we noticed that from our data, the majority of people are using credit analysis, whereas a minority are using bootstrapping,
Okay.
I just can't remember, do we have the option to close it without sharing it?
No, because I think it basically has almost like a workflow, which is we don't have it's closed both of the two poll questions. I wonder if we can add a poll real quick. Let's see. Oops. Polls, manage polls. Okay, so I'll create a new poll. What color is your favorite? Red, blue, yellow, and save. Okay, and now I'm going to share with you the what color is your favorite. I'm going to launch that. Please respond. Okay, so I've got 100% response of blue. I'm going to close the poll.
Oh, you still went back to the waiting room screen.
Yeah. I guess you right after you close that poll, you need to go back to sharing your screen.
What if we don't close the polls? Can we do that?
I think that's why I couldn't navigate, click on the presentation.
Yeah.
Yeah.
So I can't remember. Do we have an option to not close it and just keep going?
I don't think we'd be able to see results.
No, there's something, a little window. Can we add another poll? Sorry.
Yeah, we'll do that right now.
I think there's a little box that comes up that says something about you have to close the poll box, but
You don't close it, it'll stay on your screen.
Oh, really?
I don't
Okay.
know.
Yeah, I think there's no way. Yeah.
Well, we'll see. I'll let you know what happens when this one comes through.
Okay, our next question is about your favorite person. Is it Cookie Monster, Astro Boy, or Wonder Woman? If you could please respond.
Try to just go back to the presentation and try to keep quiet.
Okay, we have 100% of responses in, and Cookie Monster is by far the winner. We
So
have a winner.
yay. I see a little flag here that says poll open. Poll must be closed to enable screen sharing. So you do have to close it.
Right. So now,
Yeah, so you're really going to close it and then reopen the presentation.
okay, now go to screen sharing again and hit share my screen.
Where is that?
So, oh, here. And show my screen.
There.
Now, do you have it back? Yeah.
Yeah.
Okay, so after we close the poll, we have to immediately go back and share our screen.
Do you know how many clicks are required to conduct a freaking poll?
I know.
Okay, hold on. Let's test it one more.
Let's test it now for real, where you show the results and then we close.
Okay.
You remember that process.
Oh, yeah, God. The other thing, I was wondering, when we can have as many organizers as we want, and to manage the questions, what we can do is one of the organizers, like if you made me an organizer tomorrow, then I can pass questions to the people who should address those questions. So if a question comes in about bootstrapping, I can direct it to Vadim. If a question comes in about sensitivity analysis, and so forth. So throughout the presentation, you don't need to worry about the questions coming in. I could pass them to you guys. You all have laptops open, and you join as organizers.
Okay. Then we make Larry an organizer too, I guess.
Yeah, and that way the questions, you can address the questions that get passed to you.
And I think we can just if we have our own laptops that we're not using for the presentation, we can actually read the questions and assign them to ourselves.
That too, yeah.
So when Larry can address them to us.
Because each organizer has the ability to right-click the question, and then there's an option that says assign, and then you'll be able to assign it to any of the other either panelists or organizers.
Yeah. I just don't want to I just don't want to do that without practicing it first.
Yeah.
I mean, definitely for the next webinar.
Okay.
But
Well, that's fine.
But
I'm just if you think that the questions were smooth enough at the end the way that it was.
I think we kind of scrambled to figure out which questions we're gonna answer quietly.
I think it wasn't as scrambled as you guys think. On our end, I think it sounded pretty good. It seemed pretty smooth, like the transition to, I think I'm going to pass this one off to Vadim, like that kind of stuff. It sounded okay on our end, especially because you guys have the barrier questions that you're going to ask first. I think you're going to give yourself a little bit more time. Another thing to kind of think about is how many questions do you want to answer? Like, are you going to, say you get 10, are you going to answer all 10? Are you going to answer 5? Because I think that'll help you guys too, determining what's manageable for you as well.
So I was thinking that we would probably answer as many questions as we can within the time frame, which is until 1 o'clock.
Yeah.
With webinars, my experience has been that the questions are usually the most interesting part of the event, the presentation, especially if there's active questioning.
Sure. Yeah, I was
going to say too that I like those first 2 questions. I think those can be our canned questions for tomorrow. And just right off the bat, we do the one about sensitivity analysis cutoffs, and then the one about is bootstrapping sensitivity analysis. And that will give us maybe a couple minutes to get organized.
Yeah.
Okay. So I've just opened a poll. If you could please take a look at your screen. We want to know what came first, the chicken or the egg. Okay, I'm going to close that poll now.
No debate about this.
And 100% of respondents agree that indeed the chicken came first. Thank you for sharing that. I will now return to our presentation.
Yeah, you got it back.
Yeah, but you shrunk it up. You shrunk down.
Yeah. I think when you just clicked on the, I don't know exactly what you pressed, but it came back earlier
Then
than
before.
I expected. Like, maybe you clicked on the screen or something?
You from
Okay.
current slide.
There we go.
There you go.
Well, as long as we have a screen next to us, I'll look at it to make sure that I'm keeping up with a full screen, returning from the poll to the deck. I think we can do that.
I think if that's the only way, how you did it in this practice is fine.
Okay.
Can we take a look at this cover slide real quick?
Yes?
Is there any way of putting stress down along to the next line?
Yeah. No.
Stress. After uncertainty, colon. Yeah, there we go.
Pressure coming down on me. Do, 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 do.
Oh, I didn't even know we had
Pressure.
stress testing. I thought it was bootstrapping and sensitivity analysis. I don't know how stress testing got in there.
Okay. Nobody's even listening to me announce the title.
Right. It's a good thing we caught that before tomorrow.
Okay.
Yeah,
Is that better?
that's funny.
And the other thing on the slides, you have a copyright of 2013.
I know. You know what? What happened was I went with the slide template that had a 2013 copyright.
Uh-huh.
We can try to change it before tomorrow. We should actually.
It just means, to me, it looks like the data's old,
Right.
like it's an old presentation. So if you can, that'd be awesome.
Okay. Yeah, we'll work on that.
And then,
If not, we know that Victoria and Sue are masters at this.
I think the copyright was like
there you
embedded.
go.
in the
It's right
template.
there. Do you see down at the bottom?
Okay, right there.
Yeah, it is as easy.
Oh, you can just type over it.
Yeah.
Okay, you can type over it. It'll be easy.
Yeah.
Okay.
It's easy.
It's only once because it's a mastered stuff.
Okay, good.
So then if you go to your actual slideshows, let's see if it changed all of them.
Oh, I haven't changed it yet, sorry.
Oh, okay.
Okay.
Okay, but that's all you have to do. Great.
Yeah.
And for some reason, we lost you for a minute.
During the conclusion when you switched back to Larry.
Right before the Q&A. Was that a natural pause, or was that we lost a connection?
Right before switching to...
Well, we were kind of shifting around, but I didn't think it was too long of a pause.
Okay.
I didn't notice anything.
Oh, it just wasn't long enough that Victoria and I were like, like, what do we do? So I don't know if maybe it was just on our end or something. So we could have lost some sort of internet connection or something. I don't know.
Yeah.
And then
It's starting to get really annoying hearing you both. Echoes like.
Okay, we'll work on that. We're like jumping around over here, like crawling all over each other's chairs and everything. So we gotta work on being faster about that, I guess.
And then I guess the other thing is, who all do you want to be an organizer tomorrow?
Oh, if you can add Jonathan, and
Okay.
what's your email address, Jonathan?
Hill, H-I-L-L.
He's our new guy.
Hi.
And Larry as well.
Okay, great. So we'll have what I'd like to do is have me also be as an organizer, just so I have controls if I need to take over.
Yep, absolutely.
And if you all wouldn't mind sending us the final presentation so we have it as a backup.
Yes, tomorrow morning we'll send it to you.
Perfect. One other thing is, Larry, when you were concluding, you mentioned how you were going to send the follow-up email today. I think we're waiting a couple days after, so just say we'll be sending you a follow-up email shortly, and not really give them a date, just to manage expectations as far as that goes.
Okay, sure.
And the other thing I want to just warn you guys about, we're going to have to watch this registration really closely, the numbers, because the number of attendees you have is 96 right now, and the maximum you can have is 101.
Yeah, I think we're not going to get 100% participation, so I'm not really worried about that. And like maybe 10 people are FI people as well, so.
Right, and I'm not worried about it either. It's just that, if we start getting closer to those, if we start seeing people really come in, they do cut it off after, actually they usually give you about 20 extra, so about at 120. But if for some reason tomorrow we had a huge amount of people register and attend, we will go on and contact GoToWebinars and just ask them to up, if it's okay with you all, to up your
our allowance.
Yes.
Yeah, that would be a great problem to have. So
wouldn't it be?
we'll
Yeah.
see.
Yeah. So, and then tomorrow, can everybody get on a half hour early?
Yes, we're definitely going to be. We'll start setting up like an hour early, and then we can start talking half an hour early.
Okay, great. And I can go in. Well, this is the question. Do you want me to be the FI consulting or the webinar at FI consulting person?
Yeah, I was thinking that it's better if I do it. The reason why is that I think the very first practice we did, Victoria did it, and there are just some little bugs by doing that, where she logged in as webinars and I was I had the control. So I think the way we've done it for the past few sessions, where I log in as webinars, and then I start it, and then you get control, I think that's, just stick with that.
Perfect, perfect. Just wanted to make sure. Okay, great. So we'll make sure to tomorrow or even maybe later today, we'll send you the actual link for the organizers to click on to enter the webinar. Rob, you will be webinars at FI Consulting, so you'll actually go to webinars and log in that way. But everybody else will have a link, and it's a link that is specific to being an organizer. So if you all have registered for the webinar, do not use the registration link, because that just makes you a participant or an attendee. It doesn't make you an organizer.
Okay.
Okay, so I will, when I send you that link, I'll make it perfectly clear that this is the link you need to use, so that you're actually able to share your screen and be a presenter and all that. So.
Okay, do you mind sending the recording link again to sometime before, tomorrow morning?
Absolutely.
I just want to check it out really fast. Okay.
Absolutely. I think it sounded really good, guys. I really did.
Mm-hmm.
Yeah, I think these practices have really helped, and I think we could have done it today as is, and I think it would have been fine.